Good day. I'm teacher Jessica. Our lesson for today is Newton's third law of motion. Newton's third law of motion helps us understand what happens when two objects come in contact or interact with each other. If you throw a stone into a body of water, what happens? There is a reaction. A splash of water goes up. According to Newton, for every action, there is an equal and opposite reaction. For every action, there is a reaction that is equal in size. When you throw a small stone into the water, a small splash is created. And when you throw a bigger stone, a bigger splash is created. If you try throwing different sizes of stones, you would generally find that the sizes of the stones match the sizes of the splash. While the size of the action and reaction are the same, Newton also tells us that the direction of these two forces are different. In fact, the reaction is always in the opposite direction. This explains why a stone which fell downwards created a splash which went upwards. Here is another example. When you sit in a chair, your body exerts a downward force on the chair. The chair then exerts an upward force on your body. Imagine if the chair does not react to your action, or it does not exert the same amount of force towards the opposite direction of your action, the chair will not be able to hold your weight and it will collapse. Now let us review what we have just learned. For our first exercise, solve the crossword puzzle by completing the sentences with the correct word. Number 1, across. Reactions always go in the direction of the action. Number 2, across. An action and its reaction are equal in. Number 3, across. Newton's third law of motion explains what happens when two objects. Number 4, downwards. Forces always come in pairs. Each has a reaction. Number 5, downwards. The force of an action sends a reaction in the opposite. Number 6, downwards. Every action and its reaction are in size. Okay, time is up. Now let us answer the crossword puzzle together. Number 1, across. Reactions always go in the opposite direction of the action. Number 2, across. An action and its reaction are equal in size. Number 3, across. Newton's third law of motion explains what happens when two objects interact. Number 4, downwards. Forces always come in pairs. Each action has a reaction. Number 5, downwards. The force of an action sends a reaction in the opposite direction. Number 6, downwards. Every action and its reaction are equal in size. In our second exercise, study and analyze the following photos and identify the action and reaction forces involved. In this photo, the diver pushes the diving board or springboard downwards. As a reaction, the diving board pushes the diver upward into the air. In this second photo, the man, using a paddle, pushes the water backwards. As a reaction, the water pushes the boat forward. In this third photo, the swimmer pushes the water backwards. As a reaction, the water pushes the swimmer forward. And finally, in this photo, we see a group of birds flying. Is the law of action and reaction present in this scenario? Yes! The flapping of the bird's wings pushes the air downwards. This creates a reaction. The air beneath the bird's wings pushes them upwards. Now, always remember, Newton's third law of motion is also called the law of action and reaction, or law of interaction. It implies that for every action, there is an equal and opposite reaction. Forces always come in pair, equal and opposite action-reaction force pairs. And the forces of a force pair do not cancel because they act on different objects. That is all for today. I hope you learned something new. Thank you for watching.